So, the first derivative test basically say that a relative maximum, like this guy and this guy, is gonna occur exactly when my function change from being positive to being negative. I mean, when my derivative change from being positive to being negative. And the relative minimum is gonna be basically when my derivative change from being negative to being positive, from being negative to being positive. Because well, that actually corresponds to when my function change from increasing to decreasing and from decreasing to increasing. So, if I want to use the first derivative test to identify the relative min-max of my function, I need to find when this guy, first derivative test, I'm gonna need to find the interval where f prime of x is positive or negative. And I already have the derivative here, so that should be pretty easy to find the interval where this guy is positive or negative. Now, if you remember, how do you find when this guy is positive or negative? Well, I know it's going to be 0 at negative 2 and 1. So on the number line, you can mark out negative 2 and 1. Now what you can do is, you can plug in on each of the piece here. The value of this derivative will either be all positive or all negative on each of the piece. So you can just plug in one of the numbers to see if they are positive or they are negative. Let's say if you plug in a number less than negative 2 into this guy, you will get a number that is positive. So on this interval, your derivative is going to be positive. And then they will actually change sign. If you plug in a number between negative 2 and 1 into this guy, if you plug in 0, you will get 6 times 2 times negative 1. So you get a negative number, so this interval is negative. If you plug in something bigger than 1, let's say you plug in 2, you will get 6 times 4 times 1, so it's positive. So this interval is positive. So your derivative is positive here, negative here, and positive here. So when x equal to negative 2, your derivative change from being positive to being negative. And if you look at the rule, that's going to be where my relative max are. So that means my f of x and when x equal to 1, my derivative changed from being negative to being positive, so it's going to have a relative min. When x equal to 1. When by 2, I mean negative 2 by 2. So that. If you were to plot the graph for this guy, by the way, your graph should look like this. It should go up until it x equal to 2, and after 2, let me kind of draw it down here. If you were to sketch the graph of this guy, it's gonna look something like this. Okay, it will go up until it hits negative 2. It will go down until it hits 1. Something like this, and after 1 it will go up again. So here, this is the graph for the for this function. So it's just a sketch based on just the plot here of the derivative. So that's the first derivative test. That's the orange thing. I need to find the derivative and find the interval where the derivative is positive or negative. However, there is also a thing called the second derivative test. The second derivative test will use, on the other hand, the second derivative. If the first derivative exists and is equal to 0 and the second derivative is less than 0, then my f is a relative max. And on the other hand, if the second derivative is bigger than 0, then it is a relative min. So for the second derivative test, you need to find the second derivative. So to be able to use the second derivative test, that means the derivative and the second derivative better exist. So let me try that there. We have already found the first derivative, which is 6x squared plus 6x minus 12. So the second derivative should be pretty easy to find. The second derivative is going to be just 12x plus 6. So that's pretty simple. So I need to use the test when x equal to negative 2 and 1. So let me try that there. So f prime of negative 2. If I plug negative 2 into this guy, I'm gonna get, let me see, negative 24 plus 6. So that's negative 18. So that's less than 0. When it is less than 0, my test basically say that it's gonna be relative max. So that means f of x has a relative max at x equal to 2. So that agree with the answer when I tried it the first time. Now if I try to do the same thing when x equal to 1, if I plug in 1 into this equation, I'm gonna get if I plug 1 into this equation, I'm gonna get, let me see, 12 plus 6, so that's 18 bigger than 0. So that means my function has a relative min. But it should be negative, by the way. So that's another way to identify whether a function is whether a critical point is a relative min or a relative max. So you have two ways to find it: the first derivative and the second derivative. Now then, the next part E, asks to find the absolute max and absolute min of the function on the interval negative 3 and 5. So now this part concerned with the absolute min and max. So the absolute min and max, once again, are the actual highest value of the function or the actual lowest value of the function. Now, how to find the absolute min max of a function on the interval? Well, you have this theorem. The extreme value theorem said if a function is continuous on a closed interval, then the absolute minimum and absolute minimum exist. So to find that, what that means is to find the absolute min max, of a function on the interval. You actually need to find all relative min-max. And find the endpoint value. So you need to find the value of the function at all relative min-max and then find also the endpoint value. And you compare this to whatever is biggest is going to be your absolute max, whatever is smallest is going to be your absolute min. So because this function, I want to find the absolute min-max of this guy on the interval -3 and 5. So -3 and 5. But I knew it has a relative max at -2 and a relative min at 1. So it looks something like this. So the problem is I don't know whether when my x equal to -3 and 5 are the function value at these two guys. Is it bigger or smaller than the relative min-max that I have found? So I actually need to find the function value at this 4 points and compare them to find the actual biggest value or the actual smallest value. So let me try to find that one by one. So let me see. I need to find 4 value: f of -3, f of -2, f of 1, and f of 5. So let me actually compute it one by one. F of -3, I need to find the function value now. So make sure that you plug into the right function. So I'm not talking about the function value, not the derivative. So the function value is going to be, let's see, 2 times -3 cube plus, let me see, 3 times -3 square minus 12 times -3. I have computed this before, so I'm just gonna write the answer, which is 9. Now when n is equal to 2, I do the same thing. I plug -2 into my function. So once again, I'm gonna get 2 times -2 square plus 3 times, cube. 3 times -2 cube minus 12 times -2. So I get, let me see, I get 20. F of 1 is gonna be 2 times 1 cube plus 3 times 1 square minus 12 times 1. And that's gonna give me -7. And finally, f of 5 is gonna be 2 times 5 square plus, cube plus 3 times 5 square minus 12 times 5. And that's gonna give me, let me see, 265. So now I have 4 values that I have to compare. I have 9, I have 20, I have -7, I have 265. And it's easy to see the smallest of all is this guy. The biggest of all is this guy. So my function has an absolute min when x equal to 1. So that means my absolute min is going to be this guy, and absolute max is going to be this guy. So far we talked about how to find the min-max of a function, the relative min-max. You can just find the derivative and see if they are equal to 0 and see if they exist or not. If they're equal to 0 or they doesn't exist, then that's the critical point. So that's your candidate for the relative min-max. There are two ways that you can use to verify if they are min or max or false alarm. There are first test or second test. Now, to find the actual absolute, which is the biggest of them all or the smallest of them all, you just have to find them all. You need to find all relative min-max and find the endpoint value and see what is the biggest of all or what is the smallest of all. And that's going to be your absolute min and absolute max. Now then, the last topic for the day is the inflection point. The inflection point, once again, is going to be when my function changes the concavity. So a concave up look like a cup, like this piece. Concave down look like a frown, so that piece. So the inflection point is going to be when the inflection, the concavity of the function change. It's going to be that guy. And you can see from my sketch of a function, we should have a inflection point around there, but I need to find the exact value of the x value when that happens. So that comes to the last two bullets. The function concave up when the second derivative is bigger than 0, and concave down when the second derivative is less than 0. And it's going to be an inflection point either when the second derivative is 0 or doesn't exist. Now then, let's actually let's actually find the inflection point for this guy. We have already computed the second derivative there, so let me actually go ahead and just use that. The second derivative is going to be 12x plus 6. This guy always exists, and it's going to equal to 0 when x equal to 1/2, I mean negative 1/2. And if I were to sketch the graph of f prime of x, it's pretty easy to see that 12x plus 6 is going to be negative in this piece and positive in this piece. So that means it used to concave down when x is less than negative 1/2 and concave up when x is bigger than negative 1/2. So it actually changed the concavity at this guy, which is negative 1/2 that I have here. So that means my function has an inflection point when x is negative 1/2. Show up. Okay.